Hi guys, over the past couple of months I've been exploring what it's like to build on the Solana blockchain. I wanted to create more complete end-to-end project, so I have decided to build a very basic options trading protocol. Now I would like to walk you through the functionality and show you parts of the implementation along the way. So the core idea is for an admin entity to be able to create a market for a specific asset token, for example Jupiter or SOL, liquidity providers to be able to deposit tokens into that market, and users can buy options against one of those markets. Now, as you see, the front end is run locally. However, the options protocol is deployed on mainnet, and we will be able to see all the transactions submitted go live on the Solana Explorer. With all that said, let's focus on the Jupiter market. Now, as you see, it already has 100 tokens deposited and some premiums accrued from trading activity I did before. And for 100 tokens, it has minted 100,000 tokens in 1:1000 ratio. Now, as I tap another 100 tokens, I will get an estimation of the LP tokens quoted right here. And let's see the calculation for this one, which will be in LP shares. The LP tokens are calculated by very common formula, which represents the user's share of the pool, which is represented by the incoming token amount divided by the total reserve. In our case, this is the tokens deposited plus the premiums accumulated. The goal is to this formula aims to benefit the liquidity providers that have already deposited and premiums are accumulated against their funds. So let's send this transaction. Let me check if I have this amount. Liquidity provider 200 Jupiter tokens. Okay, 100 tokens and just a little bit. Okay, let's see. They are the amounts are correct. Okay, and we see the market state is updated and our transaction succeeds on the Solana mainnet. Let me quickly show you the state for each how the state for each market is managed. It can be best shown in the admin market create instruction. And there are basically 4 PTA accounts that are responsible for this. One mint account for the LP tokens. We have a market account and 2 token accounts, one to hold the funds for the market and the other token account to hold the fees generated by trading activity. And let's go over to the market account real quick. It's just pretty basic fields to store the accounting, and for this, the last ones I will get back a bit later. Okay, let's change the wallet account now and buy an option. I will switch to this one, option buyer, and refresh the. Now, when I chose to make an options protocol, I underestimated how complicated the process of pricing an option is. So for this project, the pricing model will take into account only the expiry window and the market historic volatility for that specific window. This historic volatility is basically for the current token. So for this purpose, I've made an off-chain worker service written in .NET right here that will compute the historic volatility every couple of minutes and push it on chain. We can see it more accurately right here. Basically, it will fetch the price of a token over specific look back period and time interval that is for each expiry window. Then it will compute the historical volatility, and the results are pushed on chain to update the market account I showed you before. I have set up Azure Key Vault to manage the private key for this one, but I suspect there might be slightly more better and sophisticated approaches for this one. And we can see the last submitted transaction going right now. It fetches the data from Birdeye, from the Birdeye API, and we can see the transaction just being submitted that just passed. And market 2, this is the Jupyter market, is updated with those values. Okay, let's go back to buying an option. Let's fill the form and see what happens. We will set 30 cents as strike price. We will pick 4 hours as expiry window, and let's say 150 as quantity. As we enter strike price, pick expiry window, and quantity, we get a premium quoted right here. Now, the user is able to pick a slippage tolerance for the premium that he is about to pay. Since the premium must be calculated also on chain, and we cannot have the premium be passed as input for obvious security concerns. Let's go over the premium quickly. So how premium is calculated? We take the strike price picked by the user. We get also the spot price for the current token from Oracle, and we have the expiry window, a reference to our market, quantity, and option type. The expiry window is converted into time to expire in seconds, and that is represented as fraction of the year. We also get the volatility from the market by the user choice of expiry window, and those parameters are passed down to calculate cow premium function. And what this function does is basically it sums the intrinsic value of the option plus the time value, where the intrinsic value is how much an option is worth if exercised now, and the time value is the extra value from volatility and the time to expire. Not going to go any deeper in the math now. You can check the full implementation in my GitHub repo. So let's finally buy those options. We'll set a 0.5 slippage tolerance, and we'll buy one, and we can see it succeed. Passes on mainnet. Okay, confirmed, and we'll buy cheaper because I'm running out of tokens. Okay, the user state. Let's quickly go over the user account. The user's positions are stored in a user account that can hold up to 32 options. Now, this limit is higher in practice, especially with zero copy serialization, but as we go higher, a trade-off decision has to be made between paying more for storage and potential performance cost versus the practical necessity. Now let's exercise those options and lose some money to the liquidity providers. I have intentionally left the expiry window validation check in this instruction in order to be able to complete the demo. Okay, one passed, and I need to fix my user interface. Okay. Let's go back to the liquidity provider account and borrow our LP tokens. Liquidity provider 2, and let's check our tokens. There are 0.103 as before. Go to the Jupyter pool, and we see there are some more premiums accumulated. We'll go to withdraw and paste and burn all of our LP tokens. And as you see, we will get a higher number than before. And our transaction succeeds on mainnet. Okay, and we can check in our wallet. We have more tokens than before. All this code is published in my GitHub repo if anybody wants to check it out more in detail. Thank you so much for your time, and have a nice day.